Awesome. Well, welcome to everyone who just joined. This is our Tech Talk skill set and mindset of an AI scientist and engineer as part of the AI engineering job fair. We will start in about 2 minutes, so please just get comfortable. And you will see in the right hand side, we have a chat. So, in the meantime, please feel free to let us know from which country are you joining today. And we are going to check out some of the answers that you guys have, also to relay that to Yi-Hsuan right here. Seems that we don't have a lot of answers right now. Okay, they're starting to kick in. That would be people from the US. We have from Denver, Colorado, Sacramento, also from Honduras. Okay, we have people all the way from Taiwan. That's awesome. Romania. It's 3:30 a.m. So it's great that you guys are here, just waiting to hear from Yi-Hsuan. Then we have Canada. That's awesome. Okay, so I think we can just get started. And again, just want to welcome everyone to this event. Thank you for joining us today for skill set and mindset of an AI scientist and engineer as part of the AI engineering job fair. And this is actually our last event of this series. So thank you to everyone if you join our previous events. This event is brought to you by ARC. We connect great developers with companies around the world. And if you'd love to learn more about the companies that are hiring and what we do, we're going to share the link in the chat. Today, we will be learning about different engineering roles from early stage startups at Google and also how AI products are crafted. And to make sure that you take full advantage of this talk, please feel free to drop all of your questions for our speaker in the Q&A section. You will see we have a chat and we have a Q&A box on the right-hand side. So if you'd like to ask Yi-Hsuan here something about his talk, please just drop it on Q&A. And don't worry about making notes immediately since we will send the recording your way. So without further ado, I would like to welcome our special guest today. He is Yi-Hsuan, the AI and machine learning tech lead manager at Google. He has been from a researcher, scientist to startup leader and engineer right now. So Yi-Hsuan, welcome to this stage and feel free to get started.
Yeah, thank you for the introduction, and also, good to see you guys still staying late, like until the end of the entire event. Yeah, it's really my first experience is to have such audience from everywhere, and yeah, I'm also from Taiwan, so yeah, have fun having lunch, having breakfast during the talk. So let me share the screen first. Okay. Okay, is this all good?
Looks good.
Okay, cool. Right. So as Gina mentioned, the topic I'm going to talk today is to really share my past experiences being different roles in AI companies, including scientist, engineer, or even in a startup, which is a exciting environment compared to different companies. And let's just jump into the things I want to talk first. So basically, yeah, I want to let you know, my previous journey towards this AI and or specifically in computer vision. In my early stage, basically, I did my PhD in computer vision, and then as most of the PhDs, we start doing the research, publishing papers, either doing our internship or even after my first job, I'm still publishing papers, as scientists and working on this AI since like early 2012. And as most people know, AI started evolving a lot since the deep learning comes to play around 2017. So this means actually lots of cool or real applications that actually becomes in reality. So that's why after I did my research work, I start thinking maybe we should do something cool that can really make the technologies really useful in the real world. So apparently, doing the research cannot make it happen. So that's why I choose to join a startup, a very early stage startup called Fire. So I will introduce what we were doing in the past. But basically, when I was there, uh, it's really a very different environment compared to a research environment because I need to really think of what kind of technology can make the good product, and this product need to be appreciated by common people, and so that's why I take the leading position in the startup company, and fortunately our startup, which is Fire, got acquired by Google last year. So that's where there's a reason why I'm at Google now, and I mean, it's a very different thing, jumping from the startup to the bigger company. But this also actually let me understand lots of things that can happen, and also what is the differences between a startup and a bigger company. And right now, I'm still leading like a scientist and engineers as a tech lead manager, and try to foresee future products at Google. All right. So by the way, I'm happy to take any quick questions, during the talk. So feel free to just raise your hand. All right. So next, I want to introduce more a bit on the roles I was doing. So this is, basically when I did, as a research scientist. And I'm not trying to scare you guys, and I don't want to go to details. So, but I can imagine like most of people see these figures, like usually you see in the papers, you probably cannot really understand what the research scientist is doing, but just think, oh, maybe something very cool, something very interesting. Yeah, so this is probably what you feel now. Like, what's this? Like, what's this, right? And this is actually also very different from the product you might see using some AI technologies. So then this is also, but when I was doing research, I didn't realize can be a problem for most of the people not doing AI research. So that's why I try to jump to like a product space and see what we can do there. So this is gonna be a video I want to show when I was at Fire. Let me stop here. Oh, sorry. Let's see. Okay. Um, okay, right. So the product we were building is trying to enable AR navigation on the cars. So you're gonna see a screen on the car, and we want to bring a new driving experiences when you use the navigation applications on the car. So you're gonna expect that. Okay, so then just let me play the video first. And this is all the real recording we do on the car. All right, so yeah, I just want to give a quick example here, and because I'm gonna also use some of our previous product example and consider them as some case study in my talks in a minute. So just giving you a rough idea about what we were doing, and apparently what you see, I will say it's not complete. I mean, it's still a pretty early product stage, but you can see that it should require lots of AI technology to understand the surrounding scene when you are driving. Okay, but I'm happy to take any quick questions. Yeah, if not, I'll go. I will continue. Okay, I'll continue first. Then okay, then you might wonder like what I'm doing here at Google, and but yeah, as you know, it's confidential. I cannot tell much, but I will try to use some other terminology to talk about what I learned when I work at Google, like bigger companies. Right. So the next thing I want to share is like as I mentioned, so if I want to have an AI or machine learning product, certainly we need some technology or need some research. Then the problem is, what is the trajectory between this research and the AI product? So most of people might think, okay, it can be very straightforward. But from my previous experience, actually can be different scenarios when you work on different product, or even when you work, in different company or different environments. For example, when I was in a research lab, just doing pretty much the fundamental research, we actually couldn't even know what's the product we are pursuing. Like we don't, it's pretty vague. We just feel, oh, maybe we do this research, then we can do that. We can have some product, like something like that. But the definition is usually pretty vague. And the problem is like, even usually when we even have the technology, to make a good product, we still need lots of different effort. For example, we need to design a good UI user interface or user experiences. And even to make it work, we need to consider lots of engineering effort. So those are tons of the things I didn't consider when I work on the research. And then, so that's why I jumped to the startup. But the reality is like, even in the startup, we might have a better product definition because otherwise we will die soon. But the problem is like, we will gonna have limited time. There's gonna be lots of competitions, and the funding may not be sufficient to support research development because usually it's require pretty specialized experts. And so this is gonna be another challenge. Even we might have a pretty clear roadmap in terms of product, but we will have other constraints. Then you might think, okay, now if we in a bigger companies, problem solved. We have time, we have resources, we know what the product we're gonna make, right? But as far as I can observe now, usually it will be like this way. So even you have the technology, but there are lots of things you need to go through in a big company. That there might be some other, like logistics or different technologies. They might you figure out what is the best one we're gonna use. And in terms of to make a product, things might need to get resolved or get converged in a longer horizon time frame. So there's actually still lots of challenges to make the AI product work, even you are in a bigger company. But what I mentioned is like this may not be true for all the company in the world, but I just want to roughly mention this is the trend I'm seeing when I work in different companies. All right, so some of the things I actually learned during this journey is like, yeah, as you can see, if you work in different company like research or startup or bigger companies, because the environment is different, the resources is different, then this means that you might need to have a different skill set and you need to think of the problem in a different way. Then one thing I usually see is like we need to understand. Once you understand your working environment, then you will need to see what is the missing pieces in your team specifically, or maybe in your company. They actually make the product deployment less efficient. And one thing is like, do you have the product definition, or do you need actually stronger research development? Or when even you have the research, do you have enough engineering support to make the final good product? And then overall, if you want to make a good product, you also need, for example, the UI interface or different, or product manager to really collaborate together to make everything, maybe not perfect, but at least something satisfactory for the common, users. All right, so I can stop here a little bit and see whether any quick questions I can take. Okay. Yeah, I think I will move on first.
Yi-Hsuan, there are 3 questions if you would like to take those first.
Oh yeah, sure. Let me take a look. Yeah, so I have another screen, so I cannot really face the camera. Let me check the question. Yeah, the AR road trip video, 2023. Yeah, okay. I assume everyone can see a question, so I don't gonna repeat. So I'm gonna answer the first question. Like basically, what is the technology around this to improve the AR, navigation things? So my answer will be, I mean, most of the time, most of the technologies are ready, but the thing is putting them together, and making a good use cases is tough. But of course, the technology won't be perfect. For example, um, even in the self-driving industry, like they might adopt the similar technologies we had before. It's still not perfect. But for AR navigation, we don't really require the level of the self-driving technology. But in terms of perception or scene understanding in AI, there's still lots of things to solve. But for example, like if there's a certain object that we don't see before, then the AI will have difficulty to recognize that. So there's still lots of things to handle. Yeah, but I think the things are improving pretty fast now. Oh yeah, okay. Same question like how do you get an idea? Okay, I didn't get an idea. I mean, our co-founder got an idea. I mean, our co-founder started having this idea since 2017. So late was a age like when the AR or VR things, become popular. So that's why our co-founder got the idea. Okay, the third question. Okay, cool. I think the third question I can answer in the end. It's more like a general question. Yeah, so I'll remember this. Yeah, so let's move on. All right. So before diving into more specific skill sets or mindset that I probably learned from my previous jobs, I want to just quickly, give an overview of how we did to launch an AI product. I mean, this is probably not true for all the product, but this is something I think is general enough. So for example, in order to get an AI model, of course you need data. I mean, data is super important. If you don't get the data, then basically you can't train any machine learning models. And once we have data, you need to decide what is the infrastructure you want to use. For example, there are many popular open sources like PyTorch, TensorFlow, even now the latest one's JAX. And then the thing is like once you get a model trained, you will need to decide where you deploy a model. Most of the use cases might just rely on the cloud, like you just put a model on the cloud so that you can do the cloud access. But some other specific application may rely on the phone, or even for us in the past, is using deploy on the car. So different deploy environments will require different, design of the model or different constraints of the deployment, footprint or the memory requirement. Then in the end of a product, it still needs some other engineering or, for example, UI, UX design to make it, to make use of the model deployed. Right? And in order to do this, I mean, one part of the important thing to in this entire cycle is to really identify the technology behind the model you want to deploy, or even improving the research or technology to make the model better so they can support your product. And of course, the other thing that I think people are talking a lot now, in which is super important, is ML ops. Basically, it means like, how do you know your AI model is doing the right job for you? You need to keep monitoring, or see what is the corner cases might actually crash the product, or your, or user, make the user experiences worse. Then this is actually becomes very important, and lots of staff actually are doing the ML ops, and this is basically to support the entire machine learning development and also the product development cycle. All right. Then let me continue. So then the next thing I want to start with is I have 3 case studies, and in general, there's no wrong or right answers, but I just want to, in general, give everyone a chance, maybe even provide any opinion, or I will try to, just outline some of my personal suggestion, like when we start thinking of this case study. So the first one is pretty simple, like based on the development cycle we have now. So how do we start this? Because this seems like lots of details here, right? So for example, if I want to give you a product, then what is the most important thing that you might think of in the beginning when you start this development cycle, right? And I'm gonna just jump to maybe my questions here, and the specifically for scientists or for engineer or for any of other different roles, you might think the problem very differently in terms of the entire cycle. Like for scientists, for me in the past, I just want to think of, then what is the machine learning task? What are we gonna solve, right? But I may not really need to know the product. But for engineer or even other roles closer to a product, then the question will become, if I have a machine learning model, how can I make a great product? So this will actually let you start the entire development cycle in a very different way. For example, for scientists, important thing is data. And maybe how do we design a model? Maybe we need to take the ideas from academics or from some papers. Then the third thing is like, how do we evaluate or benchmark the models? And for the engineers, the important thing is like, how do we get the entire development cycle ready so that we can really do the testing and maybe really optimize the runtime or the footprint. Then in the end of the day, when we really launch a product, how do we scale up, to make it efficient for everyone to use? And these are usually not the considerations that scientists will focus on, but because of these, mindset differences, usually this will require more communication when both the scientist and engineer are working on the same development cycle. Right. So I'm going to probably stop here and maybe just see whether any of the folks has any ideas or any feedback. Yeah, or just put any comments or any things in the chat or in the Q&A. Yeah. Okay, so I'll just stop. Continue. Oh, I think there's something in the chat. Oh, no. Okay. All right. Then the second thing I want to go further is like, okay, now we already have the development cycle. We know how to train a model. We know how to do the testing. And then we even have a final product. And I'm gonna use this example, because this is our previous product. So I mean, I'm pretty free to use this example, and I can also, I'm fine if anyone want to judge this. So for example, for in our AR navigation, we have this, we need to guide people where to drive. For example, you see the arrow on the road, basically telling you this is the way you are driving, right? Then this is basically the end of the product. I mean, this is what the user will perceive, in the product. Then the thing is how to know whether this is good enough, right? And my question is like, okay, again, from the scientist's view, point of view, or engineering's point of view, they can be totally different, right? Because in order to get the error on the road, it's not something immediately coming from the model. For the model, you might want to detect the lane lines. And from the lane lines, you can know where you're going to drive. So then this becomes the issue, right? So for scientists, maybe, we usually design different metrics, like for example, recall, precision, and then they can take them from the academia so that we can really understand how our machine learning models perform, right? And maybe also need to decide, okay, what is the metric we care more? Maybe it's today we care more about recall, or maybe this product does not require a lot of recall, but we cannot make mistake. Then precision will be more important. But from engineering sort of view, because the model's performance is not the end of the cycle, right? The end of the cycle is actually the product. Then the problem becomes how do we define the product performance? And also, like, because sometimes if the product actually might be sensitive to different corner cases, but usually corner cases may not be reflected in the model performance. Then how do we identify the corner cases and really improve the product performance? And the third question I have usually, having lots of debates is like, for example, let's say I can give the 10% better performance in a machine learning model, but this 10% model performance, gain might not be able to translate to a real performance gain in the real product. So usually there's some gaps between this, between the model performance and the product performance. So how to, really make sure the model performance is meaningful for the product performance is actually quite a challenging situation. And the other situations I can really think of, like, for example, right now, LLM, like a large language model, is actually super popular, right? And I'm not sure whether you guys also see, like, some other news, in the past, like OpenAI, release a new model, claim it has a better, like model performance. But actually, this actually got criticized by lots of people saying the entire experience is getting worse. So this is basically the gap, because it's actually pretty tough. Sometimes it's pretty tough to measure the product performance. So this is I think this is one interesting problem we can solve when we launch the AI product. Okay. Let's see. Okay. So let me continue now. And following the next thing is like, once maybe we can already know, we have a few bunch of, product features, but how do we add even more feature? For example, in the example, we have a feature, for example, we can detect the person, and this is probably easy enough, but we also want to know where we cannot drive, for example, in this red area. And also we want to show different, maybe different building or different, landmark on the building. Then we pretty much need to know where the building is. Then there are gonna be lots of different features coming into the product. Then the problem is like, usually for scientists, I mean, I will say, oh, that's pretty cool. Let's try to maybe just have a pretty strong model and solve all the problems, at once. But the problem is like, to solve all the problems at all, you need a pretty strong, support from the data. And also, it might take longer when you develop something. Like basically, you might miss lots of different challenges when you want to have a giant model and to tackle everything. And also, even you have the best model in the world, the model might need more time to do the inference, right? It's maybe getting slow. Then it will cause a problem in the entire testing cycle, like how to really know this can support the scalabilities when you launch a product. And also the thing is like, for example, if it takes long, if it fails, if some research fails, how does this impact the product or the engineering plan? So there are a bunch of different things they actually need to consider before you really want to jump into a big hole, like try to get the best model. Yeah. And for engineers, I mean, usually may not really understand, whether this technology can support new product features. Um, or whether after adding some new features, whether it will break the existing features. So there can be a bunch of different considerations because like usually if you want to get a giant model, maybe you can solve 10 different tasks, but maybe one of the tasks might get poor performance. Then it's basically might break some existing features. So this is something that we don't want to see in the final product. And in the end of the day, like how do we get a better framework to support even more features, and then this will not break anything, in the existing development cycle or existing pipeline. So these are all different considerations. And also all the gap between the scientists and the engineer. So we all want to understand this situation so that when we make decisions, so we can both know what we can do. All right. So I'm gonna stop here a bit and see whether we get any questions I can answer now. Okay. Yeah, one question is like the AR demos in Vancouver. Yeah, we had a team member in Vancouver, so that's why we got the video. But we didn't really have the office. We pretty much, our office was in Bay Area, in Redwood City, but we still have a few remote employees, everywhere, and because that's pretty much around the pandemic, so remote work is pretty much fine. Mm. Yeah, and we didn't record for the new office, and the video you saw in the beginning is actually for CES last year. Yeah, the CES in Las Vegas. Yeah, okay. So the skills. Okay, I'm gonna talk about that. I'm not going to talk about like, for example, you need to know C++, you need to know Python, because I think for different components you will need different specific, for example, languages or different engineering skills. So I'm not going to do that, but I think I want to maybe talk more about on like how you can diversify your skills so you can, and before doing that you need to know what is the major components in the entire development cycle. So for example, this is, I mean, roughly the development cycle. And for if you are doing, I know there are engineering rules to do data curation, like try to process the data and make sure the data is in quality. So if you are doing this role, I think one good mindset is like you always need to also know what is the product definition, because you can see from data to a product, they are the farthest point, in this figure. So if you're doing data, but it's actually quite far from the product. Sometimes when you do the data stuff, you don't even know what the product look like. So this my recommendation. You try to understand the product definition and think of how you can improve the data curation effort. And the other thing is like, even you are doing the data stuff, you might not know how to train the machine learning models and so on. But it's still very nice to know, given the data you have, how can the machine learning model do, and whether there's any existing machine learning model can support digesting such a data you are trying to create. So these are, basically you don't just do the data, but you also need to understand the other portion of the entire cycle. And for example, you can, even you should try to, train the model based on your data and see how it goes. So they will require different engineering skills. Okay. So let me just finish this part. Then the second thing is like these ML ops and continued testing are also very important. But usually when you are working on such projects, you might not touch a lot, on the machine learning model training and so on. Basically, you take the models and then try to design some features they can analyze the model outputs, or monitor how your models is training. But the thing is, like, you also need to understand, like, when people developing the model training, what is the pain point, right? So I will highly recommend, like, even you doing the ML ops, you should also do the model training to really see what is the pain point. Then you can understand what you want to develop in the ML ops functions. For example, how to detect corner cases, the machine learning model failed. So these are pretty, common, pain points of the machine learning model. Then there should be a corresponding, a better ML ops, process, or a better testing process to really identify and even help model training, or even help the data collection process. Yeah. And the second thing is, like, because when you deploy a model, there can be on cloud. Cloud is a very easy environment to deploy because it does not really require the computational power. But if you deploy on phones, or even on cars, on vehicles, or on wearable devices, then basically you have much less computing power, and you will not have, you kind of will suffer from the overheads or the footprint issue. Then based on different situation, then this is also where the ML ops or the testing should help. And you really need to design for specific deployment environment. All right. And the last piece is on. Oh, I think this. Yeah. Okay. This is the piece for the product is basically also, for example, when you working towards like engineering things, like taking the model outputs and try to make it as a product, then sometimes the one issue I can observe is, like, engineers may not know the limitation or why the model produce such output. Then so basically, if you also have a knowledge to know what kind of machine learning model can do, then you can have a better sense how to process the machine learning outputs, and then do something maybe even more creative, or maybe more productive. And of course, like, you also need to design like a scalable and reproducible framework. So in this case, even the model is different, because the model can get updated very frequently, right? So even the model is different, you can still make sure your product will not be get affected, significantly. Okay, so finally, on the research side, I assume that most of the people here are engineers. So, but the thing is, like, for researcher, we also need to know, again, like, for example, if I can get a pretty good model accuracy, what does this mean to the final product accuracy, right? So again, the example is like for the generative AI, usually you can only play with that and also try to feel whether this is doing a good job. But at least for now, I don't see this a pretty standard way to really know whether the new model can provide very smooth, user experiences. So this is something we all need to work on. Yeah, and of course, like research will need lots of engineering and data support. And the other way is the same. I mean, data support and engineering also need to know how the research can provide. All right. So before going to some key takeaways, I will check some questions here and see whether I can answer fast. Right. So I'm checking one question regarding what is the technical skills for the AI scientists engineers. And I think it's a good question. Like between entry level and experiences professions, I'll leave this question in the end. Okay. Okay. I think there's okay. I'll probably leave all the answers in the end, but let me finish the talk I have now. Okay. So anyway, in the end of, I want to just quickly summarize the key things I have been talking in this talk. So, for example, if you are engineer, scientist, you want to make sure you understand each other, understand the pain point, and I mean, specifically, I think this is also very useful for you to know what is a career path you want to go. For example, are you happy with dealing with the data? Are you happy with working on the ML apps, or actually you want to do a little bit more on the machine learning model? So these like different things that if you know like the pain points, then you will see what is the things you want to solve, and also this will be also helping the end-to-end development cycle better. I mean, for example, I've been doing the research and also responsible for the entire development cycle, from the data collection towards the model deployment, and also try to see what's the product we need to envision. So that's actually really helpful for me to understand what's the pain point when we really decide something, like when we have some, for example, resource issue, or we need to decide the direction. So this will be very helpful. And if you are a scientist, I will gonna, or if you are a team leader or manager, I think there's a similar question there. So basically, I will say, if you have a big picture, then you basically know what's, from the product, perspective view, you know what is the technical need you need to at least have in the entire cycle. Then you do the forward thinking to tackle each of them. But without having the knowledge of what you need, if you just tackle whatever you see in front of you, this can be very dangerous, because you solve one bug or solve one issue today, this may not really benefit the end of the day, like when you want to launch a product. So always think backwards from the product, and then you know the technical need. Then you can really see what is the key bottleneck you must solve. So this is the first thing I learned. And the second thing is like, I mean, is everyone know like collaborations is very important, because one product will need different roles to really make sure it can get through the final stage. Yeah, and again, the final thing is like, it's also need different perspective. For example, even for example UI or UX or PM person, they don't really understand the entire cycle, but they can also provide very critical perspective from different viewpoints. So they're actually pretty useful even for the engineering team to consider. All right, so yeah, so this is the end. I think there are lots of questions, so I think we have still around 15 minutes. So I think we can answer the questions now. Yeah, thanks for listening. Yeah, let's get to a question. Okay, so let me say, I'll just maybe answer some technical question first, and then we can go to the skill set things. So first of all, the question is like, what does improving a model means? All right, so so usually, for example, if you do the object detection, you want to detect the objects, or you want to classify the image as some certain categories, then you will need to define some certain metric, for example, recall, precision, or F1 score, and so on. So usually, what the model improving means is like whether we can improve such metric we design, right? And then the way is like, for example, you need to get more data, or you need to change the model architecture, or as you mentioned, like you need to change the loss function or change different, outputs, from, output format, like to make it, supported to different, loss function design and so on. Right. Yeah, but again, I mean, the point is like sometimes if you can improve the model, this may not mean you can really improve the product performance. Okay, so let me check maybe whether there's any other technical questions. Okay, I see one. So how do you make sure when improving giant model that the results are also improved, but not, making it worse? Right. It's a very good question. I don't have a very nice answer. So basically, so usually when you have a giant model, it's still likely you get better performance. But the problem is like you might miss some of the corner cases because, like, for example, if based on maybe you have a testing set, maybe let's say 10,000 images, right? So you might get like 90% accurate, but the rest of the 10% might be very tricky. Then usually the things like if you get to the giant model, you need to check those corner cases, and then you can really see whether your giant model is improving or not. If it's not, even the overall performance might be better, but if you are losing some of the corner cases, that means the model will not be acceptable. Yeah, so this is basically the way when you also do testing, you need to pay attention to the corner cases. Okay. Okay, I think we're getting more questions now. Yeah, I'm trying to organize similar questions first, and but let me see. Okay, what's the interesting you are currently working on? I can only tell I'm still working on something similar. They enable the AR navigation you saw in the video. The technology is similar, but that's all what I can tell. Yeah. So basically, still the AI or machine learning for scene understanding and perception. Right. Okay. So I'm going to just start from the bottom. In the Q&A. Oh wait, who comes first? I should maybe choose some who come maybe on the top. The top should be the first one, right?
Yeah.
Or if you need some help, Yi-Hsuan, we can do it together. However, it's easier for you.
Okay. Yeah. Sure. That would be nice. Yeah.
Okay, awesome. Okay, so I'm gonna go from top to bottom since the top ones are the first. You already answered to some of that, but Vancouver one.
Which ones have we answered already?
Yeah. The first one I haven't answered. Yeah. So I think as
Yeah.
a IC. So but honestly, I'm right now still managing a team, but I still need to do my work. Even previously, when I was a startup, I was the leading position. I still need to do the work because we don't have many people. But in general, I think I would recommend still doing the IC work. I mean, even you are managing people, it's still good to do the dirty work because entire machine learning AI field is moving very fast. So if you kind of give up doing the dirty work, then it's very easy to um, to get lost of what's going on in this field. So I recommend even you are a manager, you can still do the IC work. And I'm still doing that. I'm pretty happy about that. Yeah.
I think the next two you already replied, the one from Dan and
Yes.
probably Jonah from the AR road trip video you shared now. How much would you say
Yeah.
the technology around it has improved?
Yeah, I think that's the answer. For maybe Ted. For Ted. The
How the
next
tech
one.
lead of machine learning team onboards new engineers into a new project.
Yeah, yeah. Yeah, it's a good question. So I think I also see another question about whether you are entry level or more experiences. But I think this is also similar question because when we want to onboard someone, it also depends on your previous experiences. If you are really entry level, usually we should start from something very concrete and maybe not super open because in the machine learning world, many questions can be super open. There's no certain answer, right? So it will be better to give a more concrete project, like for example, just give a machine learning task, or even give a feature in the ML apps, so they can really ramp up the people easier. But of course, for more experienced people, if they already did lots of project regarding developing machine learning model, or even construct the entire development cycle, then I think it would be nice, to give more challenging, task even in the beginning. That's fine. I mean, depends on. I mean, if you are in a startup, maybe you will need someone who can really do the challenging things in the beginning. But if in a big company, there will be a different story.
Next one from Luke. I think you already answered that. And then
Yes.
Jonah has a great question, but you might want to read that one yourself,
Yeah.
Yi-Hsuan. It's
Yeah. Okay. So this is a question I can't really answer. Yeah, because this is a little bit about the entire strategy at Google. So I can't really answer this, but I mean, Google is improving the Google Maps experiences a lot, right? So you can imagine, what's coming in the future. Yeah. Yeah. Sorry, I cannot answer too much. Like the slide I show is confidential.
then I think the next one already you touched on that a little bit, like skills from entry level, experienced professionals. But do you want to add a little bit more on that?
Yeah. Good. Sure. Right. So, yeah, I think if it's an entry level, certainly, I mean, the basic, if you are working on the machine learning model, not a research, but even just train your own model and so on. I think the basic knowledge is very important, or even start from something very concrete machine learning task and then get it done and then see the result and try to analyze and then see and also try to do this loop, like if something is not working, go back to the data and try to do the data curation on your own. And even you can gradually bring the ML apps to help you debug your machine model learning algorithm, or try to monitor different machine learning models. I think that's already pretty good. And if you are more experienced, I think the thing is like you'll probably want to oversee, more on the product side. Like, what if you can make this machine learning model work? How can you bring this model, to something further? Like, how can this, help, the product deployment? And even you want to see whether you have any deployment requirements. So because like I mean, after the model is trained, there are actually tons of different steps before going to the deployment stage. So there will be different engineering effort you also need to get familiar with, and also this will get you closer to the product side, and then you see really how you can change your model, even the entire, architecture, and then have a bigger influence on the product. Yeah.
I think we can move on to Jonah's question. A little bit down there. How do you make sure that when improving giant models that the results are also improved and not deteriorate? Do you have any tips on testing, things to avoid?
Oh yeah, I think I mentioned. I mean, basically the corner cases is really super important. Yeah, I think I touched this a bit, so we can go to the next one. Okay, the next one, job opportunities. Oh, my team is hiring. So, I mean, in general, Google. I mean, Google, the hiring process at Google is not based on each team. Basically, it's usually there's you can find any job positions online, and if you apply, and then you need to go through the general interview, and then there are gonna be team matches to see whether you are a good match. Yeah. So, for my team, I can't really tell, but I mean, now we don't, but maybe next year we will. Yeah, hope so. Yeah.
The next one from Romana.
Yeah, I think this is done. The next one. Okay. This one is also done. Maybe from Oleg, the advice to give someone become a store leader or influencer. I mean, my advice will be, get your hand dirty first. Even in your current role. But if you get bored, try to find different things. And then, for example, you try to touch all the different aspects in the entire development cycle. Yeah, for example, if you are doing more on ML ops, maybe you want to find something on the machine learning model side, or you want to take care of the data, or want to closer to a product. But as soon as you get to see all the entire things, then you will have a better idea how the entire field or even the product should go, and or whether you want to introduce even better in development cycle to make the entire product cycle more productive. Yeah, so I would just get your hand dirty and try different things. Yeah. Oh, link to the PowerPoint. I'm fine to share, but we'll see probably how to do this, right?
Yeah, maybe if you would like to share this, you can send it to me, and I can send it to the participants later.
Okay. Sounds good.
Awesome. And maybe we take one more question since we just have 1 minute left.
Yeah. Okay, maybe the bottom one. So how do you get started with learning machine learning from a full stack or development background? Yeah, so again, my background comes from research. So I was also a little bit struggle when I go into more engineering. But for most of the engineering, if you want to really go into this, full stack, I think there are lots of online resources. Like for example, online courses that you can learn, like just even check the basic, models and play with that. And because PyTorch, TensorFlow, they are all open source, and you can also use, even you don't have a GPU, you can maybe I don't know, maybe it's a little bit pricey, but at least you can also use cloud, Google Cloud or AWS, right? And I just say Google Cloud because I'm from Google now, so they use Google Cloud. But I mean, lots of online resources, and the things like really need to find time to really play with that and get your hand dirty, and see whether you like it. I mean, if you like it, and then you can start getting some more experiences, then you will go farther and try different things in the entire machine learning development cycle, and then gradually find your own path. Yeah, I don't know whether it's a good answer, but yeah.
Thank you so much, Yi-Hsuan. I think in terms of time, we will wrap up here. But of course, if there are any more questions, we are going to leave your socials here. So in case people want to connect with you and probably ask you further questions. But again, thank you so much for joining us today. And thank you, everyone who just shared really great questions and everyone very engaged with this talk. I think we really learned very helpful advice. And this is the end of our chat. And again, we're going to be leaving Yi-Hsuan's social media in the chat. And if you enjoyed this session, want to learn more about what our companies are doing, we are also pinning all the relevant links in the chat. So thank you so much for joining all of the talks in the AI Engineering Job Fair. This is our last event. And yeah, feel free to stay, connect, share your LinkedIn's in the chat. We're gonna leave this room open for another 5 minutes or so. So yeah, thank you so much, everyone, and see you soon.
Yeah, thank you, Gina. Yeah, thanks.
Thank you, Sean.
Thank you.